Hey guys, welcome back to the Pepcoding. So in this video, we are going to discuss our next question, that is distinct absolute array element. So in this question, we have an sorted array of sizes and we need to tell how much number of distinct absolute values are present in the array. So this type of array that we have given, and it is in sorted order. Okay, so we need to tell how much amount of distinct absolute values are present in this array. So first we are finding the distinct numbers in this array, that is -3, -2, -1, 1, 3, 4 and 5. These are the distinct number in this array and we need to tell a distinct absolute. So just finding the distinct absolute. Now the distinct numbers are -3's absolute value is 3 and we are also want the count here. So -3's absolute is +3. So adding 3 here and increasing the count. Okay, now this is done. Now -2's absolute value is +2. So we are update this here and increasing our count as 2. This is also done. Now -1's absolute value is +1. So update this into this and increasing count. So this is also done. Now this +1. So the -1's absolute and +1's absolute is same. So we cannot add this element again and again. So for this, 1 is already in the distinct absolute. So we cannot add 1 here as well as 3 here because 3 is already present in this. Now 4 is new. So we can add the 4 here and increase the count. Now 5 is here. Now add the 5 here and increase the count. So these 5 elements are the distinct absolute element in this array and we need to return this count. Okay, so for finding the distinct element in any array, so first approach that comes in our mind, that is by using hash map and hash set. So main thing in this question is the properties of this question, that is main thing. First thing is array in sorted order, and second is we need to solve this question into O of one space. So we cannot use the extra space, extra memory here. So we cannot use the hash map and hash set. So for so the optimal solution, we need the optimal solution here. So for solving this question in O of one space, let's discuss thing. Let's try. So this is array 1 2 3 and 1 2 3. Okay, 3. So in the -3 and +3 we got only one absolute, same absolute. So for finding this and this we need 2 pointers. Okay, at this point we need 2 pointers, and if we are at here and at here, this element is same as previous and this element is same as next element, so we need also these two. So we are just starting with previous and we are just using the previous and next pointer here. Okay, now let's try with. So our I at 0th position and j at 8th position. Okay, now our previous point is placed at somewhere here, that is -infinity, and the next point is placed at somewhere here, that is +infinity, and our count is 0th position. 0th. Now our count is 0. So at the array of I absolute, array of I's absolute is 3 and array of J's absolute is 5. So at this position 3 is less than 5, that means 5 is greater than 3. Okay, so in this array, because it is in sorted order, so it is possible that we can find 3 into this portion. Why? Because it is in sorted order, so we are giving the main priority to the greatest element. Why? Let's see. First just we are doing first iteration over it. After that again I will explain you. Okay, now we are giving the priority to the greatest element in between these two, so 5. So we can say that this is the first element, because of this is the first element, then we can easily say that this is a distinct absolute. Okay, this is a distinct absolute. Increase the count and adding it at the next point. Okay, and decreasing j, that means update our j point. Okay, now again, is array of I is absolute, means array of I is absolute is 3 and array of j is absolute is 5. Again 5 is greater than 3 now at this point, but at this point 5 is appeared first. That means in the distinct absolute we have the 5 element, and for that we have the count as well. So for increasing the count, then we need to check that is array of j's element is same as the next. At this point, what is the store in the next? At this point, next is store the next element of this point. If we are at this point, the previous points store the previous point of this point. Okay, so we are checking that. Okay, just give a second. We are checking that here is array of j is equals to next. So this is the duplicacy. This is a duplicacy. So we cannot add this element into distinct absolute, and we cannot increase our count. So decrease our j, update our j here. Now the absolute of array of I is 3 and absolute of array of j is 4. Okay, now again 3 is less than 4, that is 4 is greater than 3. So again we are giving the priority to 4. Okay, now we are checking that is for is it is the 4 is distinct absolute or not. For checking that, we are in comparing this with the next element. Is 4 appear first? No, it is not appear. That means is array of j is equals to j next? No, it is not equals to next. So we can say that 4 is the distinct absolute, and we can increase the count as well. Okay, now before update the j, we need to update our next as well, that is next equals to array of j, and now update the j as well. Now at this point, okay, at this point, this is a very important point. So absolute of array of I is 3 and absolute of array of j is also 3. Okay, now these two are the same. Now at this point we got one distinct absolute. Now for updating that we need to check that is 3 appear previously, is minus 3 appears previously, is 3 is equals to 4, is minus 3 is equals to minus infinity. No, it is not. Because of that, because of these conditions are false, we can increase our count and adding the distinct absolute as 3. Now increase I and increase j. Before increase I and j, first we have to do update our previous as a minus 3, that means array of I, and next as a array of j, that means 3. Okay, now increase our I and decrease our j. So at this point, now just see carefully. Now at this point, okay, at this point absolute of I is 3 and absolute of j is 1. Now 3 is greater than 1. Now 3 is greater than 1. Now we are giving the opportunity to 3. Why? Because it is the greatest among them. Okay, among these two. Okay, now is 3. Now is this 3 minus 3 is appeared first. Yes, it is appeared is the previously. We are checking that is minus 3 is equals to previous. Yes, it is previous. So we cannot we don't have any new distinct absolute. So we cannot do increase our count. So here we are just increase our I. Before that, first we are increasing our update our previous. After that, increasing our I. Now at this point, minus 2's absolute is 2 and 1's absolute is 1. Now again 2 is greater than 1. Now we are giving opportunity for to 2. Just check that is array of I is equals to previous. Is array of I is equals to previous? No, it is not true. Then we have new distinct absolute. So we are updating this, increasing the count and updating the previous here, that is minus 2. and increasing the count, increasing the I, updating the I. Okay, now at this point, absolute of minus 1, 1, absolute of 1, 1, both are same. Now for for at this point, we need to check both side, previous and next as well as next. So at this point, we have minus 1 and 1 as 1 and 1. So we are checking, is array of I is equals to previous? No. So the first condition will be true. Is array of j is equals to next? No, it is not equals to next. So the second condition is also true. So we can easily add this is a distinct absolute, and we can increase the count as well. So this is the approach to solve this question. So let's try. Let's again parse over it. Let's give a minute. Let's again parse over this array. Okay, now our I is pointed here, j is pointed at here, our previous is pointed at minus infinity, and next is pointed at plus infinity, and count for now is 0. Okay, now we are checking that is absolute of array I and absolute of array j. Now at this point, 5 is greater than 3, 5 is greater than 3. So there is a possibility in this portion that we can find 3. Okay, why? Because it is in sorted order, so we are giving the priority to the greatest element in between them. So 5 is, now it is the first element, so we are checking with this. Next, yeah, is 5 array of j is equals to next, is array of j is equal to next. So it is false, and we are increasing our count by 1 and adding this into distinct absolute, that is 5. Okay, now update j, update next as a 5. Now at this point, again this condition, again we are checking that 5, and at this point we are checking that is 5 is appeared this at this time first time? No, it is not appeared this time for the first time. Okay, now we are checking that is array of j is equal to next. Yes, it is equals to next. So we are just decreasing our j, updating our next by this, and now checking for this. Now array of I is absolute is 3, array of j is absolute is 4. Again 3 is greater less than 4, that means 4 is greater than 3. Again we are giving the priority to the 4. Now just checking that is 4 appear first or not. Now just check that 4 is 4, array of j is equals to j, next, it is not equals to next, so we can say that it is also a distinct absolute, and we are increasing our count. Okay, now update the value of next as array of j, update the value of j as a j minus minus. Okay, now our array of I at the third point and array of j as a third, means array of I is absolute is 3 and array of j is absolute is also 3. So this is equal. So this is a very important point. Now we are checking that is 3 appears first time or not, is this 3 is appear at the first time or not. We are checking this array of I is equal to previous. No, it is not true. Okay, we are checking at this point is array of I is equal to previous, or that means and is array of j equals to next. If these two conditions are false, both conditions are false, then we can increase our count. How? Let's try. Minus 3 is equal to minus infinity. No. Is 3 is equal to 4? No. Then we can say that 3 is a distinct absolute, and we can increase our count here. Okay, now add the array of j into next, add the array of I into previous, that is minus 3, and increase I and decrease j. Now at this point let's check absolute of minus 3, 3, absolute of 1, 1. Now here 3 is greater than 1, so we are giving the priority to 3 here. Now 3 is checking that is array of I equal to previous? Yes, it is equal. Then we can't do anything because it is already appeared. Now update this is a -3 and update the I. Now minus 2's absolute is 2 and 1's absolute is 1. So again 2 is greater than 1. Now again we are checking that is -2 is equal to previous. It is not equal to previous because it is a new distinct absolute. So we are adding 2 here, update the count, again update the I and update the previous as well. Now our I and j is 1 equals to 1. Now both are same. So now we need to check that both, that means is array of I equals to previous. That means it is not equals to previous. Is array of j is equal to next? No, it is not equals to next. So we can say that 1 is also a distinct absolute and increase the count. So now this is the approach to solve this question. So I recommend you to pause the video here and code by yourself. Now I assume that you are doing your code by yourself. So let's start with the solution. So doing this full screen, so we are using 3 pointers here, that is I at 0, 4 pointers, j at array dot size -1, previous point at int underscore min, next point at int underscore max plus infinity. Okay, and 1 is a count, that is 0 for the first time. Now if I is less than or equals to j, while condition, in the while condition, at this point we are doing, we are checking the both side, and adding them here, -1 plus 1 and increasing I and decreasing j. At this point our while loop will be terminated. So the while loop condition is while low, that means I is less than equals to j. So in this condition, first condition, we are checking that is abs of array of I, is absolute of array of I equals to absolute of array of j. If these two conditions are true, then if these two conditions are true, let's first write second condition also, is absolute of array of I is less than absolute of array of j, and the last condition is absolute of array of I is greater than absolute of array of j. So when we are in this condition, that is absolute of array of I is less than absolute of array of j. So in this condition, so at this point, okay, just give a second. So we are at this point, I is here, j is here. Now at this point 3 is less than 5. At this point what we are doing, we are checking that is if array of j should not be equals to next element is infinity and its previous element is -infinity, not equals to next. If it is not equals to next, then we can easily increase our count by 1, and after that updating our next point as array of j. Okay, updating our next point as array of j, and after that decreasing, that means update our j as well. So at this point we are checking that its array of j should not be equals to next. If it is true, then we are increasing our count here by 1. After that updating our next point as a array of j. Okay, now after that updating j, that is j minus minus. Now in this condition, in this condition, we are checking that is array of I is not equals to previous, then we can say that it is a new distinct absolute and increase the count. So if array of I is not equals to previous, then we can easily increase our count, update our previous with array of I and update I, that is I plus plus. If both are same, if -3 and 3, that means if 3 is equal to 3, if the absolute of array of I is equal to absolute of array of j, then we need to check the both side, previous side and next side as well. So first, if these conditions are true, that means if array of I is less than, sorry, is not equals to previous, and array of j is not equals to next, if these two conditions are true, then we are increasing count here. Now updating the value as well, where in the previous and next as well, and increasing the I and j, updating I and j. So at this point, previous is equal to array of I, next is equal to array of j and I plus plus and j minus minus. So from this function we need to return count. Okay, now this is our code. Let's try to run this code. So at the 8th line we got an error. This is array, not AEE. So it is accepted. Let's try to submit this code. So submitted. So let's try to dry run, small dry run over this code. Okay, now this is the array. Okay, this is our array. This is our array. Okay, now let's take a snap of this code. So this is the code. Now we are checking that at this point I is here, j is here. Now we are checking that absolute of I and absolute of j. Our 3, absolute of I is 3 and absolute of j is 5. Is absolute of I is equal to absolute of j? No, it is not equal. Is absolute of I is less than j? Absolute of j? Yes, it is true. Then we are doing what we are doing. We are checking that our next point is this infinity, previous point is minus infinity. Okay, we are checking that is array of j is not equals to this. Is array of j is not equals to infinity? Yes, it is not equals. Then we are increase our count by 1. After that we are adding this element into next, that is 5, adding array of j, and after that decreasing our j, updating our j here. Okay, so now at this point we are again checking that what we are checking is our absolute of array of I is 3 and absolute of array of j is 5. It is again 3 is less than 5, that means array of j is greater than array of I. So we are checking again, is array of j is equal to next. If is array of j is not equals to next, then we are increasing count. But here array of j is equal to next, so we are just updating that into next and just decreasing the value. Now at this point 3 is less than 4. Now again we are into this look into this condition, and again we are increasing the count by 1. That means count here 1 and now 2. Okay, again we are updating our value array of j and j minus minus at this point. Now absolute of array of I is equal to absolute of array of j. Now 3 is equals to 3. Now this condition is true, so we are checking that into the both side. The previous is minus infinity and next is 4. So these two condition is true and we are increasing our count here. After that we are increasing our previous as minus 3 and next as a 3, that means array of I, increasing I plus plus and decreasing j. Okay, this condition. So this is the dry run for this code. So I hope you understand the question and the solution of this question. So thank you for watching.